Greetings and welcome to the Minnesota Stormwater Seminar Series, co-sponsored by the Water Resources Center and the San Anthony Falls Laboratory, both at the University of Minnesota. I am John Gulliver, and I will introduce our speaker. Dr. Harry Zhang is the Research Program Manager on Integrated Water and Stormwater at the Water Research Foundation, or WRF, where he directs the research portfolios on stormwater and sustainable integrated water management. Harry is also the section editor on water sustainability for the Encyclopedia of Sustainability, Science, and Technology. Harry holds a PhD in Civil and Environmental Engineering from the University of Virginia and is a registered professional engineer. Harry's expertise are stormwater and flood management, integrated water management and planning, watershed management and stream restoration, decentralized systems, and climate impacts on water quantity and quality. Harry has also served as a math coach at local school and volunteers to provide assistance to national math competitions. Today, Harry will talk about a topic that is important to all of us, life cycle costs of green infrastructure. So it is my pleasure to welcome Harry Zhang.
Thanks, John, for the introduction, and then I'm very glad to be here. First I want to say, I want to share some experience from the Water Research Foundation, which all of you, and also, and this is also a good opportunity for me to interact with your local expert panelists to exchange information specifically on Minnesota stormwater issues. So here's an agenda of my presentation. So I want to first introduce, tell you a little bit about the Water Research Foundation. And then we use a one water approach. And then I'm going to zoom into specific on this CLASIC life cycle cost tool, which is now part of the EPA Green Infrastructure Modeling Toolkit. In addition, Water Research Foundation also funded an effort develop this tool called a triple bottom line benefit tools. That one can be used in combination with a CLASIC tool. Toward to the end, I want to mention a couple other research on the wet weather and stormwater management, maybe as a resources for you. Finally, give some sort of a summary and also and the path forward. So let me start by give a little bit of introduction on this Water RF, I think the Water Research Foundation. I think if you look at the sort of a logo here, so if you ever heard of the Water Environment Research Foundation or Water Reuse Research Foundation or simply Water Research Foundation, and then the answer is pretty easy, okay? There's a combination of all those. So this is through the merger. So right now, the Water Research Foundation is a national research foundation focused on applied water research. We represent approximately 1,200 subscribers, including utility, municipality across the country, in some other continent as well, and also consulting engineers, manufacturers, part of this network. The Research Foundation hosts an online research library of more than 2,300 completed projects with a value of about $700 million. Many of the research products, I think, are publicly available. So I think, later I want to introduce a couple of them for your reference. And also in terms of stormwater, the Research Foundation currently supports the host of the world's largest body of the stormwater BM best management data. This is called the International Stormwater BMB database. So I want to talk about a little bit before getting to talk about the CLASIC life cycle cost tool and the triple bottom line benefit tool. I want to using two slides talk about first one, talk about this one water approach at the Research Foundation. So one water essentially is a basically integrated approach. And then here's a sort of a one diagram showing some of the 7 elements in here. I think as you can see, many of the components relating to wet weather, stormwater, here's the flood protection. one of the important philosophy or concept here is to view water more than just a service provision. It's a key component of livable cities and community. So this is embedded within the One Water approach here. And then here's a sort of a holistic approach to weather and also stormwater management. We use like a 3-pillar approach. The first pillar is a performance. For example, you want to design your infrastructure both green and gray, and then can meet the regulatory compliance goal. And then this may including like a runoff volume reduction, the pollutant load reduction. The second piece is really the cost. It's not just the capital cost, but also the operation maintenance cost. So in the one term would be the life cycle cost. And then you want to bring the benefit into the holistic piece here, because the economic, social, environmental co-benefit from, especially from green infrastructure, also important. In terms of weather problem, I think we're talking about 3 systems here, like a municipal separate stormwater sewer system, combined sewer system, and also flood control systems. So I think I'm going to be spending my core time talk about this classic life cycle cost too. First, I want to acknowledge, I think, the support and from US EPA for the research funding, and also with some matching funding from the Water Research Foundation. Here's a list of project team members. I want to thank you for their support. And also, there's a couple of national collaborating organizations such as Water and Environment Federation, American Society of Civil Engineers, and also American Rivers. So let's starting with this acronym CLASIC. Okay, you wonder what a CLASIC is. I think so. CLASIC is a decision supporting tool. So what does the CLASIC stand for? So CLASIC stands for community-enabled life cycle analysis of stormwater infrastructure costs. So as again, this is a part of the EPA Green Infrastructure Modeling Toolkit. Just to help you to understand, thinking about this. Other tools within the EPA Green Infrastructure Modeling Toolkit, such as the EPA SWIM model. So you can sort of think about that way. And also actually a CLASIC tool using some algorithm from an EPA SWIM model. So in essence, I think CLASIC tool is a user-informed screening tool, and then they incorporating life cycle cost framework to help the decision making. And then within the CLASIC tool, you can evaluating the green infrastructure, gray infrastructure, and also somewhere in between. So when people design a tool, the first thing always in mind, what I designed this tool for? So what are the decision questions CLASIC tool seek to answer? So here are some of those questions. So I think it really, if you have those facing a similar question or challenges, I think this may be the first thing. Hey, CLASIC tool may be helpful for you. So for example, if you have a different stormwater infrastructure scenario, you want to evaluate both in terms of green and gray, and then you want to not just consider the runoff volume reduction, pollutant removal, but you also want to consider life cycle cost, and then maybe also trivial bottom line benefit. I think like a social, environmental. So that CLASIC tool may give you a hand. And also, if you want to evaluating, like a land use, impact, and also in climate impact on the future performance of the scenario, and then CLASIC also can help you here. Yeah. Here, just using the one slide, I think talk about as a snapshot for the CLASIC life cycle cost too, and also here's the link. One later on the slide will be shared. I think Andy will share the slide. And then you can click the link and then they give you the information. At its core, there's 3 key components. The first is really the tool based on some of the algorithm from EPA SWIM model, so they can evaluate the hydrological performance, and also pollutant load reduction for your stormwater infrastructure or the scenarios. And then for the water quality parameters at this stage, I think that the CLASIC tool can evaluating total suspended solid, total nitrogen, total phosphorus, and also fecal indicator bacteria. the core of the tool is really because the name, as name bears, I think is a lifecycle cost tool. So they have the rigorous evaluation algorithm for lifecycle cost. So there's a couple of metrics here. You often heard, I think, like a net present value, and also they can give you sort of average annual cost of a design life. If you have a the design life of depending on how long you're here, this tool will give you some sort of average annual cost. And also they can give you some unit cost for scenario comparison. One of the additional thing in here, really, if you want to consider benefit, I think in terms of economic, environmental, social benefit, and then this tool give you user some control for you can select the sort of important factor, and then this tool will generating the score for you for comparison purpose. And then we have also developed a case study covering all the 9 climate regions in the U.S. And also we also developed some of the short, I think, YouTube video clip for the training purposes as a demo. On this slide, just trying to show you throughout the tool development, one of the core we're focused on is really community engagement. So starting from the tool, we want to make the tool be beneficial for community, municipality, and then also there's a different size of community and also across a different geographic climate region. This is through the beta testing. Later on, there's a stakeholder engagement, and also all the way we're doing a case study here. So now let me drill into the tool. So first thing really, here's just a key step. I'm going to elaborate in the following slide. I think. But basically, here, you can starting with, define your area or watershed, and then you incorporating your climate data, precipitation data. And also there's some built-in parameter you can select from. And then you're building different scenario of the green and gray combination. And then if you want to interest in the, the benefit, you select some importance of factor for you. And then you run a tool. You can even enter some target to compare against. So just want to give you some visual. So you can think about, this tool is a sort of, it's a GIS-based, the GIS-interfaced tool, and then you can delineate, the municipality or watershed here. So this is, I just want to show you the sort of a screenshot. I think you can select area by, different boundary, and then you can even draw some of the boundary yourself, and then and also you can select the land use. This is the web-based tool and then in the public domain. So it's really just to help you visualize. Here's a little bit of technical detail. If you're familiar with EPA stormwater management model, I think this one, maybe you can quickly pick this up. I think this particular tool using some of the core engines with the EPA SWIM model, and then incorporate some other latest other cloud technology in there. So I think the stats really you define the project area, and then you're incorporating climate and then geographic information and then rainfall. There's some model default parameters. If you have a more higher resolution parameter data, you can also incorporate in there. And then of course really building the scenario suitable for your specific municipality or your specific case. And then this is a sort of generating pre-processing information, connecting to the cloud service integrated platform. And then they're generating some of the post-processing output here. And then you may wondering, oh, hey, you talk about all this stuff. I think what are the BMP technology category currently including here? This one you can think about it. Current EPA SWIM model have, I think, 5 type of a BMP. So CLASIC build on those, and then we try to expand it into more categories. And then in some other categories, we want to give a more explicit, simulation of the BMP type, which allow user to enter some sort of parameters for better simulation purpose. So here's a list of the BMP technology categories. Again, before I show you some of the more screen shots, I think I want to go back to here. So the tool is generated for the purpose, we want to simulate like a SWIM model. You want to show hydrological performance and pollutant loading reduction, and also the core is really how does connect to life cycle cost, because each scenario may have a different life cycle cost, and also each scenario may have a different benefit. I think you want to compare different scenario in order to maybe pick what the best available scenario for your specific case. And then for the performance, I think the two connecting to this international stormwater BMP database, which have this one has been built in more than 25 years as some rigorous BMP performance data in the database. So the two are connecting to the BMP database. We have a team member also from who was expert on the also BMP database to supporting with us. In addition, this one connecting the BMP database connecting with the urban stormwater quality database. This is original from Dr. Pitt from University of Alabama. I think after he retired, he connecting with the BMP database for his the urban stormwater quality database. Here's another two information, just show you if you're interested in drill into the specific BMP type performance and removal efficiency. So here on the left side, this is the International Storm BMP database, 2020 summary statistics. The report is publicly available. So later on, once you share the slide, you can go through the link. The other piece really, in order to address, the operation maintenance cost, and before that, even the cost of tracking protocol, Research Foundation team up with the AICE. We issue some of the guidance document here on this cost tracking protocol for the operation and maintenance. And also, last thing I want to mention here, the urban stormwater BMP database also enhanced. I think is the operation management cost database. Also, it just launched early this year. And yeah. So I'm going to spend a couple of slides. I think the sort of getting into the CLASIC itself, give you some more feeling. So this one I'll talk about. You can select the area. You can see a different way how to select it. Once you select area, you can enter some of the parameters. I skipped that step here, but I want to show you zoom in to show you this building scenario. I think that here. So once you have have the set of your area, the watershed, and then you select the sort of default parameter layers, like in terms of GIS layers. And then the key part really you want to build in your own scenarios. So this to allow you to choose different, the technology, and also, for each technology type. Here showing is a rain garden, and then rain garden we conceptualize, different based on the literature review. We conceptualize into different types. The user can make a selection. For example, can be by the the classic like a size of the rain garden, and also some of the key parameters we put here like a ponding depth and filter media depth. So user can have some control in here, and also whether you have under drain or under. So this allow you to, if you have a better data, you can actually enter your. If not, you can just sort of by experience showing by using user input here. Another piece in the scenario relating to climate, I think the impact. I think that you can run your baseline, but if you're interested in generating some of the future climate scenario, and then here the tool is built in there. This is not fully finalized because, as you can see, the IPCC also released something in there. So we're using some of the algorithm available scenario in there. The other thing, sort of, we want to reduce some of the runtime. So this is a sort of a balance between what kind of complicated scenario and also the runtime of the model. Yeah. So here I want to show you sort of a combination. You can also do the combination. This is showing the climate scenario can build in there. This is also under the the scenario in there. You can try different combination of scenario here suitable for your purpose. So I think that I want to, given the time, I want to show you a screenshot for the sort of performance, give you some sense. So once you're getting everything lined up, and then you run the program, and then the program will generating this is 3 pieces of information for you. The first one is a performance. So on this one, if you look at it sort of towards the bottom, they give you as an example here, they give you sort of percentage change in terms of volume of runoff, infiltration, evaporation from the baseline scenario. And then on the top here, there is a label lifecycle cost analysis. So you can have, they have a breakdown for construction, maintenance, rehabilitation costs for you. This is the go by the scenario. So if you look at the scenario, you have a baseline scenario. This one scenario on top, you can see there's a worst sand filter. The other scenario, green roof. I think this is just some hypothetical one to show you. You can try different combination of BMP and then run, see how. One of the unique thing here really there's a co-benefit analysis. You can see the color on the dial here. So one of the idea really is, you have a baseline scenario. Let's say you're starting with a 0, but once you're incorporating something, for example, green infrastructure or combination of green and gray infrastructure, and then you want to evaluate their benefit. I think you have social, environmental, even economic. I think that this one the dial will give you some number, and then you can become more adding more, run different more scenarios, maybe more green infrastructure, and then the style changing. And then also the other idea really is you can, let's say you run the scenario for the 2020, and then next year you have more improvement, you invest in more. And then you can run the scenario again, sort of compare across in there. So this has actually become a sort of a showing people with a progression. This is during the stakeholder feedback. This is one of the functionality stakeholder really interested. They like it. I think especially in the graphic design. So again, this is just want to give you zoom in for the scenario comparison. This one specifically trying to show you. You can pick a different technology, BMP, but also you can combine with climate scenarios and then, maybe run the both. In this case, trying to give you example, climate and the technology, and then climate and the technology scenario. This is maybe something the user may be interested for the scenario. I think that given the time, I want to show you this. That we have a website. We have lots of information there, and then people ask a lot about the case study. And then one particular question is really, are there any case study in my particular climate region? I think because this is a stormwater based tool, based on precipitation. So here's a national map just showing you. So through this effort, we conducted like 9 case studies. I think, we purposely blended across, the climate region, also the size of the utility or municipality, I guess, yeah. Because in some cases, if you have not enough data, you may want to choose more, the default data. But for some other community, maybe have more resources, you may have a more, your own data, and this is maybe ideally for you to incorporate some of your data as well. Yeah. This is just to show you the co-benefit, what they cover by the design. So sort of as you can see, this is cover through this integrated urban water management framework. If you think about this one water approach, we try to incorporating the one water idea here. So meaning when you are doing this stormwater management project, you're thinking some way, in some cases at least, this can help promoting one water goals. So some of the goals here, the cross beyond the just a stormwater sector. So I think that we want to give you opportunity to incorporate in that. One of the things within the tool, you can make adjustment. I think based on your specific the experience or best professional judgment, which factor you view is more important. So you can change the sort of important factor for this different category, and then eventually let model run, and then you can compare scenarios. With that, I want to switching gear to another tool, and then the message really, this another tool should be used or can be used with a classic lifecycle cost tool for your decision making. So I want to show this the interface here. So this one I want to acknowledge, I think the support from the Corona Environmental Consulting and also Kinney Zhang's consultants who help the Research Foundation with this tool. So this, as a title, see this one is quantifying the trivial bottom line benefit of green stormwater infrastructure. So this is just sort of a problem statement. I think that I want to highlight some of the keywords here. you may wondering, hey, how does it different from the CLASIC 2? I think the difference is that this keyword, I think, quantify and monetize the triple bottom line benefit. So the CLASIC 2, the co-benefit is in there. Is we use this particular project as a matching project for the EPA funded project. I think this project using we team up with a water resource economist, try to focus on is any benefit really can get down to the dollar. So how do you monetize those? I think is there any rigorous economic framework we can do that. So this will in tandem with the CLASIC 2. One is generating the score. The other one is really can generating some of the dollar value if possible. So again, this is this is through the traditional best cost analysis framework. I think you want to quantify financial, social benefit, and then over time, and also and then also who benefit. I think that's another question people typically ask. To give you a sense, this one, within those three categories, you wonder what are the specific subcategory of the benefit that this tool evaluating or can providing value for you. So here's a three circle here. On the financial one, economic one, there's some avoidance costs. So for example, if you invest on the green infrastructure, certain type of green infrastructure, you can actually save some money by maybe in order to meet the regulatory compliance. You have some you can avoid some infrastructure, or even you don't have to do a full bloom. I think the treatment enhancement. Also from extended asset life, and also if you're building like for example tree and then tree planting, you can save the energy. And also beyond that, there's a lots of the environmental benefit. I think that, like for example, water quality, aquatic habitat improvement, even the greenhouse gas, carbon reduction, and also ecosystem benefit. On the social side, I think some of them are connecting with environmental, maybe a social environmental benefit. So this one, like air quality, improvement, and also heat stress. I think if you have some certain type of green infrastructure can reduce the urban heat island impact, and also people like green space. This is a recreational, more recreational opportunity for the community, and then even you can create some more green jobs for the community, for the municipality. So how do you should want to consider those benefits? Can you really quantify or monetize those? So that's really go back to some of the research incentive. Why do we do this? I think if you do have that kind of data, in a rigorous way, can be convincing, because you can identify stormwater management alternatives that maximize community value and benefits, and also you can build support even internally within your own organization. For example, if the leadership and then or commissioner want to know, hey, I like the green infrastructure, but can you tell me how much benefit you can generate from putting more green infrastructure? And then in some cases, it become also important, for the value proposition can help, maybe for the scarce funding, this maybe can help you go, further. And also, this is also showing some team up with can be private sector, private capital, and then from you're showing the benefit, generating from those kind of green infrastructure. And at the end, really, you want to have a community support and buy-in in order to ensure success. I think whatever you do, you need to have a community support in order to maximize your success. Yeah. So this one also same idea. So we emphasize community engagement. So we pull the organization, also utilities / municipality across the country, and we even invite them to join us. I think this was 3 years ago. Have a workshop with us, talk about their specific real world need, and then something works, something don't work, or what they want this tool or some of the research foundation can help out. So this is pretty helpful. So this just want to show you sort of general framework. Again, you have a built-in this economic framework for in there, and then you wonder, hey, how about the values? Okay, my region is different from others. So this particular unit during the tool development, in addition to the rigorous, economic analysis framework, also this regional adjusted value is very important. Now, if you have a better value than whatever default value based on literature, based on extrapolation, things like that, and then you can enter that as well. And then in terms of scale, this one can give you neighborhood at the city on watershed scale. We try to avoid, I think some people say, well, is this at a design scale? I think the answer, you can use for that for the like a screening purpose, but I think it's not designed for specific design purposes. So I think, so that's why I think the lowest scale maybe you can view as a neighborhood scale. And also there's some factor because this is built on the Excel Visual Basic. I think you can also see some of the values. So if you want to know some of the detail here, I want to save this slide for you, sort of what kind of a rigorous economic evaluation method in here for each of the category of green infrastructure. Here's the dots to show you in there, and then in the report, and then they have a more detail in there. But I think that this thing or just message really we follow some of the rigorous economic evaluation framework. And also I said too is also we try to make it user friendly. This one compares the classic tool. The other one's web-based, cloud-based. Some people may feel, well, I couldn't see anything in it. Okay. And then maybe this one is a sort of a Excel Visual Basic based tool. So there's operating by tabs in there, and also you can see the value enter in a more concrete sense, and also you can see output from the output tab. And then we have also a sort of this one we want to show you is we have sort of a step-by-step guidance here as well. And then the same question. Okay, what are in this tool? I think what are the BMP type? So here's the list in here. So during the research effort, so two project team actually they work collaboratively. I think we talk about using CLASIC benefit this tool, also using this triple bottom line to benefit the CLASIC. So this has been synchronized to the best possible way as a research collaboration. The benefit is not that easy. So this is just trying to show you one of the the thinking when we embed in the tool in here. For example, if you do tree planting, and then they can touch down several categories of the benefit. I think air quality, the cooling part, and then the water quality. So and then they sometimes connect each other. So this is something I think the water resource economists really think about. You try to avoid double counting, but in some time you want to also give the credit for each of the the green infrastructure in there. But I think this is a sort of getting into the weeds of research, but I want to show you, give you some of the quick sense. In a time limit, I think I want to show a couple of screen captures. So later on, you can take a slide and zoom in to look at yourself. So this one just showing you how to establish the GISI green infrastructure scenarios, and then this is by BMP type. You can enter even the number of BMP, and then also some of the volume, some of the parameter here. In terms of the cost, I think we still this tool not only just benefit if you want to see the cost as well. This one we collaborate with CLASIC effort. So this one using the unit cost reference table. So both give you sort of a low, medium, high estimate based on literature, based on the CLASIC one. So you can pick in there if you want to see the cost value as well, using this standard, using this tool alone. And also in the benefit category, here's just a couple of screenshots, I think, showing you this is a spreadsheet Excel-based tool, Visual Basic. This is, for example, this energy saving. We have a literature value, come down to supporting this tool. And also in the tool, they allow you to do some regional adjustment. As you can see here, this one says Midwest, you can select Minnesota, and then, try to enter some of the value in there. And then another example, really, this one is a property value. Sometimes I think, based on literature, if you have a well-maintained bioretention pond, for example, can potentially increase the property value. So this one we conducted some more research in here, and also we because of variation, so we try to give using statistics that give you sort of a low, medium, or high estimate of our assumption using in there. And then you can see those assumptions within the tool. You can pick whatever best is suitable for you. Here's the output, just trying to show you, sort of eventually you can generating the different category benefit, and also and then we're pushing for the dollar value. So I think that people say, well, that's a dollar value, that's really I like the most. Okay, sure, but the caveat really, some of the things I think that maybe you have to be on the future research. We try to monetize those things we feel scientifically or through the rigorous economic framework we can. I mean, in some cases we may not be able to hard. Well, you have to make a very assumption, and then we'll just enter some of the value based on other ways to do that. So anyway, but I think they can give you this sort of output by the benefit category, and then so you can compare them. And now again, back to the case study, I think we try to test out a tool across different part of the country. One of the case study here actually based on in the St. Paul, Minnesota. I think this is a table trying to show you different benefit category embedded in these 4 case studies, and then what are the benefit cost ratio, those kind of value in there for your information. Because I think this is in Minnesota, so I want to sort of zoom in into some of this study provided by the Capital Region Watershed District. They're providing some of the data or information for us. I think that they want to acknowledge their support. So this one, later on you can look at the screen too. So again, really you have a BMP type, number of BMP, and also some of the certain BMP parameters you may be able to enter as a user control. And then this one, zoom out, I think this gives you, again, sort of a dollar value, if it's possible to generate from the tool, and then they give you some sort of dollar value. This one sort of, by the different category, and then we try to showing you one is a baseline scenario, the other one is sort of a more greener scenario. Here's the number, a couple of numbers here, maybe sounds a little bit complicated. I think, so I'm going to leave this one for as an information purpose. But I think I want to using a graphic to show you what I mean by one of the matrix. I think maybe help with your sort of a value proposition. So this particular value, this matrix is called the ratio of the incremental benefit over incremental cost. So on the graphic here, I want to show you. So they have a green one, meaning the benefit. I think the sort of a gray one, meaning the cost. So we have a 2 scenario. One is a baseline scenario, and then also the green scenario or greener scenario. The idea really is over the life cycle, the time, let's say using 25 years, the baseline scenario, they have a sort of cost, and also, they have a benefit as well, But I think that for the greener scenario, you expect that they have a greater, benefit, but also in some cases it comes as a greater cost. So what is the incremental benefit generating from those kind of incremental costs? In this particular example, I think the ratio of the incremental benefit over incremental cost is 2.7, meaning if you invest $1 more of the greener scenarios, you're going to generate a benefit at $2.7. I think this is an important one because that's why I give people a more incentive to think about that. I think this tool give you sort of putting those in a dollar value, so you can maybe and in a rigorous way, so you can use this tool. Maybe see how anything help you. With the time remaining, I just want to quickly showing some other research in here. I think essentially giving you as a references, and then of course I can come back to it during the discussion. So this is a 2 report. The first one I want to say, one of the particular BM type people interested is called a stream restoration, and then one of the things in here, people want to see, hey, can I get in the water quality credit from if I do a stream restoration? So we just released the guidance document, which is updating from 2016 guidance document on the stream restoration as a BMP credit guidance, and also for the wet weather. Sometimes climate resilience and come into play. So here's some other resources for you. The last 2 things before I wrap up, I think. Was like I think I mentioned at the beginning. I mentioned a sort of an integrated approach, integrated planning framework. This is one of the EPA sort of encourage a volunteer approach, and also we also have a research called One Water Cities. So when you're doing all this, this can be viewed as one water community. So sort of you want to for the whole community going through one water. How do you putting the things in there? So with that, I think, the sort of a wrap up of the presentation, again, the take home message for you really is, you want to consider, the stormwater management, wet weather, in a holistic way. And then, here we have a life cycle cost tool and also a triple bond tool here to help you. Yeah. And then with that, let me close out back to John.
Thank you, Harry. I'll give you my personal applause.
Thank you.
This is really interesting and a really, I think, a really difficult topic. We have a lot of questions. I'll start with the ones that have the most upvotes. The first one is, can you discuss how risk/uncertainty is approached for costs and benefits using these tools?
Yeah, so this is a great question. This is things we have been thinking through at the beginning. So like one example really, like when you're doing a hydrological modeling, or even water quality modeling, you always think about some sort of uncertainty analysis. I think we thought about that. I think the way we're using it actually, given that data availability, we're using sort of a more like a statistical based approach. So sort of like in general sense, like a confidence level. So we summarize the data, and also this because regional variation. So we sort of basically separate data into different bracket, and then within each bracket we're using sort of a statistical measure in there. In terms of like a more formal uncertainty analysis, this is the first step. We felt maybe this is a scenario-based approach. We encourage people to using a sensitivity analysis, and then later on, and then you can using some other thing in there. At this point, we're using both a combination statistical measures and also a regional adjustment approach, along with sensitivity analysis as a solution. It doesn't quite have those kind of Monte Carlo simulation yet. Yeah, sorry.
So I have a follow-on question. I noticed in the costs, there were a low, medium, and high costs. And I'm wondering, is this a range of known costs, or does this have a certain uncertainty associated with it? Is it the 95% confidence interval for the low and the high, or the 67% confidence interval, or how were low and high determined?
Yeah. So thank you, John. I think so for the when we designed the tool, I think one of the things that, because this one in the public domain, so the literature we're using sort of a public available literature, and also in some cases, we our research team reach out to the municipality. We ask for the real cost. I think and also publish the cost. I think in there. So the cost itself, as I said, have a range. I think so you have to sort it out. So this one we get into the BMP type. I think in some cases in there, and then the screen I showed you, I think maybe at a beginning was like the different type of cost. I think that's sort of let me say this: they run a statistics analysis on all the information we gathered, and then those costs they sorted through, filtered through by the BMP type, by the region, and then aggregate. So there's a little bit of filtering at the beginning, but then eventually get down. The other thing, sort of, we're using some of the data from the another software. I think they like from construction cost used. I think they also we rely on some analysis there as well. I think it's sort of answer your question, John. Is really there's some combination of the filtering the initial data, those are public available data, and also run statistic on those sort of subcategory data. But in some cases, you're running a situation where you see the common interval so huge because in certain category, the data, you don't have that many data.
So your answer is it depends.
It depends. But I think they incorporate some of the regional adjustment and also statistics in there, and then we try to use real data. And then, of course, this is one of the enhancement we could do in the future. Later on, the thing behind the CLASIC tool, to be more accurate, I think we have more data. Like 5 years from now, we have more data. We ask people to use but anyway, I think that's a short answer. Really, they incorporate the best available thinking using best available data along the way. But I think they definitely can be enhanced in the future.
Okay, all right. So the next question is, can the tool be used to optimize BMP sizing or placement, or look at marginal cost benefits?
Yeah. So that's a great question. So at the beginning, this one, the research team spent a lot to talk about that. I think, optimization is one of the things that people like. I think so. The tool really, I think they're using scenario-based approach, and then you can compare different scenario output, and then eventually making a decision making. This is a versus, like some of those kind of tool. You enter the data, you run, let the model run, and pick up the best available combination in there. So short answer, really, the tool after the long debate and then all the discussion, I think it's, they did not explicitly build into optimization algorithm, but I think that they build into sort of in the decision making, what is the best way for people to make decisions. So they have some sort of optimization thinking, but I think if you want to, to answer the question, does a tool have the sort of optimization algorithm? It doesn't have those kind of explicit optimization algorithm, but they're thinking built into it. The second part, I think, on the I think a marginal cost and then marginal benefit. I think so. This tool can generate that. I think only. I think the example. I think maybe this slide. That's one example. I think there's a classic one can so do the sort of the incremental benefit or incremental cost. I think you can using the tool, both tool to do that. One is that give you using sort of a numerical score. I think this one give you sort of $1 if possible for those categories. So you can use two together and then eventually evaluating, hey, the data makes sense. But I think both two can evaluating marginal cost and then marginal benefit. So.
Thank you. The next question is, the decision method is net present value. And discount rate is very important when you're determining net present value. So how does the CLASIC determine the discount rate and the inflation rate? The difference between those two can make a huge difference.
Yeah. So I think that's very important. I think this is also another sort of during the tool development, and then there's another discussion. I think we have a product advisory committee. I think some of the members actually brought information from National Research Council in the transportation industry. They have they use lots of things in there, and then so I think right now I think the tool sort of later on we give the user some flexibility, so which allow user to enter a specific discount rate, and then as a surrogate, inflation is different here, but I think just talk about the discount rate, so you can enter your thing in there. And also, we try to make a more conservative, meaning, in here as well. So right now, I think, we shifted sort of quote unquote shifted the, those kind of thing to the user. If you have anything in there in the report, in the supporting document, we, providing some sort of synthesize on in some cases, how people, what kind of a discount rate people have been used. But I think really, this tool give you flexibility to enter better number. But I think really there's a user input, so you can enter whatever, right? You can enter 0 or even 2%. I think all the way there. I think we come back and forth and then eventually get onto this kind of a solution. But I think a report showing some more concrete thinking how we came to that point. But I think
Yeah, in my experience, I like to use, just because it makes such a difference, I like to use the inflation rate and the discount rate to be one and the same. It seems to make the most sense to me. Otherwise, the numbers just go crazy. Okay, here's another question. Brittany Stahl asks, is this applicable for use outside the USA?
Yep. This is a common question, and then we sometimes, let me put this way, we heard a little bit of feedback. I think so. I think the answer is the two tools, they have different applications. So the CLASIC tool, I think because the original funding source from US EPA, so they focus on US I think region. And then when we build a tool, the only thing different in there, you have to incorporating, if you want to go beyond US, for example, Canada, you have to incorporate some of the layers, because this is a cloud-based system, you have to incorporate those layers in there. I think that right now, the tool, you need a little bit of customization, you to do that. But if you just ask a question, hey, can CLASIC tool right now using for region beyond the US, I think the answer is really not directly, but I think you can do it. For the triple bond benefit is not specific by region as well, but I think some of the regional adjustment parameters is based on the, as you can see, showing some of the map also based on US and then literature actually based on beyond US. So if you use the value, maybe with a caveat is not restricted by region, but maybe the data for the US is more dominant than other region. But I think literature, we try to get all the literature available. Some of the algorithm under the benefit category, they are more like hey, connecting to some sort of a existing mapping, which is US based. I think so. So general answer really is, tool is not restricted by the US, but I think right now, maybe I'll have more data coming out of the US, I guess. So when the tool doing a tool development. So.
Especially the cost of property and things like that.
Yep.
Possibly, huh? So I was very interested in your example because that brings it home how you could use this. And John Bellata asks, are there any plans to add the number of case studies summarized on the website or a way to see where colleagues are using the tool, perhaps in our state or region?
So I think this is we have been thinking that for quite a bit. I think, from the Research Foundation, one of our missions really, advance the science of water and then for the whole water sector. So this is a thing, dear heart. I think, so the general plan like these. So we have, this one through the project, we have built 9 case studies, including 2 in-depth case studies, which across the country region. And then right now, the Research Foundation funded another project, I think, trying to incorporate some of the more case studies. And then also we team up with, the two developer, Colorado State University, try to come up with something like if you like all those kind of list server, or like, for example, EPA basin model, they have a lots of swim model, they have a user group. So right now we try to do that informally because is one thing relating to the continuous funding, but I think, also how do you run this user group? But I think the intent really is, I think we try to have a more case study, and then we try to find out, some of the functionality, we can enhance. We try to get in the more like a cost data, later on into the tool. I think so the answer more solved. I think this is one of the things the Research Foundation wanted to do. I think right now we're doing sort of one small step at a time, depending on the funding, depending on our collaborator. But I think this is something we like to do. I want to see. I think it can be other collaborating opportunity or teaming for this kind of thing. And then if you have you use it to build some case study, you want to share with us, I think we definitely will encourage you to share with us. I think later on we want to have more dots in here, and then maybe another CLASIC 2 version, things like that. So.
Okay, great. So here's a question from Zuli. She asked, does the co-benefit analysis use the auto case methodology? I don't know what that is, so okay. I don't know if you know.
Yep. So this one, I think I want to thank you for that question. This is a pretty good question. So one of the things on the market on benefit of quantification is called AutoCase. This is a proprietary tool in there. For one of the things I want to give a credit, I think for Capital Region Watershed District, I think in St. Paul, I mean, they share with one of their study. I think use the AutoCase with their consultants. I think Bolton engineering for that, and then they share with us the data and then also report. So we were able to have those information, and then we using the triple bond tool in there as a comparison. So this particular case study, which I presented here, those number we sort of cross-check with AutoCase, but in some cases, there's sort of apple-orange comparison. But anyway, I think in the report, I think in the case study, we have probably 5-6 pages talking about this case study. I think there's a more technical detail, how the data, how we used data, and also how they connect in the other case. In the current project, I think later on the project, maybe we can do more, really get down to the comparison across different tools, I guess. But anyway, this is I'll suggest, I think go down to download our report and then log in, sign in the report, download the report, and then go to zoom into this case study on the sample. So.
Thank you. So I'd like to finish with one question that I have, and that is that I think that I believe that the environmental benefits are probably the most difficult to quantify. And how much is a fish worth? And how much is that fish worth, that particular fish versus another fish? And I feel as though, for example, in the St. Paul study, that's probably the old Ford plant, the Highland Park site. I feel as though the environmental benefits in that case study are underrepresented because the question is, how much is a clam in the stream that is moved from the underground to the surface? How much is a clam worth in that stream? And I don't believe that is really quantified very well. And I don't know what you have to say about that, or what's being done to do to work on these issues.
Yeah. Thank you, John. I think that's great. I think the comment and the feedback. So when we are working on this figure, I think one of the things you compare with CLASIC one, we want to ask a researcher, is a rigorous enough way you can still put in connecting the dollar. So the answer we got, I really like what you just said. In some cases, the researcher have not been there, or in some cases. So in the ecosystem benefit, this is a very hard topic. I think So right now, I think we're using more like a quote unquote simplified approach, but I still, the public available peer review thing in there to make it work. But I think there's lots of research need to be done. One example, really later last year, EPA issued another several $1 million, I think, RP just specifically on water quality benefit. I think how do you quantify the water quality benefit? I think that water quality connecting with ecosystem benefits as well. I think so. As you can see, this is 15 years ago. EPA issued RP on that. So still ongoing research in there. So Research Foundation, we're like an applied research organization. So for those kind of more fundamental research, I think we'll rely on some researchers to come with a concrete, information or consensus within the, the water sector, and then bring back, and then we can connecting building to this applied research too. Yeah. So thank you, John, for the great comments.
Well, thank you, Harry, very much for the presentation. It was very interesting, and we've been looking for this type of presentation for a long time. So you came along at a perfect time. So we will take a 5-minute break, and then we're going to come back with a panel discussion led by Andy Erickson. We have 3 panelists, and Harry Zhang will also be on that panel. Thank you very much for listening. We'll be back in 5 minutes.
Welcome back, everyone, to the Minnesota Stormwater Seminar Series. It's so good to have you here with us today. I will begin the panel discussion now. Again, as a reminder, as you have questions, please post them in the Q&A box, and I will be pulling questions from there. So to start, I want to again thank all of our panelists for being here. My name is Andy Erickson. I will be moderating the panel discussion, and it is my honor to introduce our local panelists. Our first panelist is Ross Bintner, who is the Engineering Services Manager for the City of Edina. So Ross, from your experience, how do you relate to this topic?
Hey, Andy, thanks. Looks like I'm the only one who's gone for sound quality over looks, so hopefully I'm sounding good. So I'm an Engineering Services Manager with the City of Edina. We're in the infrastructure business, provide advice for utility management. The cities in our area are the ones that carry most of the load when it comes to operating and maintaining and those long-term costs. So that's my role.
That's excellent, Ross. Thank you. It's so good to have you here and as a returning panelist on the Minnesota Stormwater Seminar Series. Our next panelist is Mike Kinney. Mike is the district administrator for the Comfort Lake Forest Lake Watershed District. Mike, from your experience, how do you relate to this topic?
Well, I think it's great. I started out as a business major and then pursued a more scientific area. So I'm really glad to see that this is being elevated farther up, so to speak. I think we can, we know how to build a lot of things and do a lot of projects, but really implementing a discussion about cost benefit analysis, and in particular then being able to compare them across certain both scale and other metrics is really important. Industry has been using Lean and Six Sigma and things like that for years. And I think it's really time that we bring it into the water resources element as well.
Yeah, I completely agree, Mike. Thank you. And thanks for being here. Our last local panelist is Tim Olson. Tim Olson is a water resources project manager and principal at Bolton and Menk. Tim, from your experience, how do you relate to this topic?
Yeah, thanks everyone, and thanks Andy. As Andy mentioned, I work for a consultant. We work for a lot of municipalities here in Minnesota and Iowa as well. But I think that when I'm thinking about cost effectiveness and how we're planning for future stormwater management, we think about regulation quite often, whether it's project to project or whether it's an MS4 permit or maybe other state-led permits. We think about regulation first, and there is a cost associated with that. Regulation is a really important tool for water quality. I think it's a necessary tool for water quality, but there certainly are costs that are associated with that. So how do we get through the regulatory piece and then be thinking about funding projects that go above and beyond, because that's, I think, where we make the most impact from a sustainability perspective.
Yeah, that's great, Tim. And we won't ask for Harry's relation. Harry set the topic here today with the keynote presentation. Thank you so much, Harry, for laying the groundwork for us today in this panel discussion. So I'm going to start with a kind of big, broad question for our panelists to get the conversation going. And this is really about the biggest benefits. So we're talking about cost benefit analysis. And what I really want to know is from each of your experiences, what have you seen as being the biggest benefit when you're considering cost and making your decisions? And not just cost of the construction, but as we saw in the presentation, the benefit or the beneficial valuation of these other parts of these projects. So what have you seen as the biggest benefits? Anybody can jump in to start.
I'll start. So I think as a utility manager, you need to have a strong business case to be able to scale up and make sure that you're really hitting your service targets. So as a stormwater utility, we're already thinking about managing multiple benefits. We want to do really good for flood management and flood risk reduction. And then we also want to do good for clean water, our clean water service targets. So we're already managing for those, and to have a really strong business case, something that really understands the amount of service you can get for the dollar and optimize that is going to be important. After that, you start to layer on all the co-benefits, but co-benefits is already part of the problem because we're looking to hit those two service targets.
Yeah, I agree with everything Ross said. I think that maintenance is a big part of that too. One of the benefits we look at is how we can extend benefit life cycles, maintenance life cycles, and what are those costs, and how do we appropriately invest in those maintenance components, and that becomes a really challenging conversation to have at the city level too, with how do we justify increases in utility rates, and what are those other co-benefits that come with expansion of green stormwater infrastructure. So yeah, it's a challenging conversation, but thinking back on the public works side, that investment in construction is only one piece, and how do we extend maintenance and reduce maintenance costs over the life cycle of the practice, and then maybe even starting to look at is a 30-year life cycle appropriate? Is 10 years more realistic, or can we make this a 60-year life cycle? We think about that in terms of concrete and metal, pipe as well. and are we replacing things sooner than we should? So yeah, it's at the stormwater utility or even just any other utility level, factoring in those pieces can be challenging for sure.
Yeah, thanks. I think maybe that I would add on a little bit is both this element of scale and time, and I think Tim and Ross touched on it some, but scale, I would look at both continued planning. We're trying to get into some discussion about greenway corridor pieces in areas that are currently undeveloped. This next ring, when you start doing the analytics of land converted away from agriculture into other uses, mostly commercial and urban, we look at creating future problems. So how can we prevent them through good design? So some of that is in the future, and looking at it, and then also what, especially when we look at it from the simple perspective of that it's tax dollars, and these are competing for roads and other services. So and this has always been a driving point from my perspective.
So those are here. I just want to add a little bit from my perspective. I think one of the things that I think let me start with. I think a lot of Tim's comments. I think regulatory important, always important here, because what we're doing for utility, the watershed, and you have to meet a regulatory requirement. And then because of that, I think that brought in sort of when you think about benefit, I think one of the benefit using different combination really help you to accomplish meeting the regulatory requirement with a more cost-effective way. So I think it's sort of an equation is like that. So in that vein, I think like Ross commented on, I think when we are working with some of the utilities, I think that they even some of the bigger ones, I think they told us they have to go beyond the utility fence line. So if you just focus on utility alone, you won't really realize those benefits, because that's really benefit for the community. I think for example, like in Seattle, they built this program at the level the city, I think, and then really so I think you have to come. And also Ross mentioned this Michael touched on sort of other thing like MS4, you have a stormwater requirement. Also, they have a flooding, which is flooding is now water quality driven. So that and then in there, I think if you focus on just the regulatory compliance, and then that's one key piece of it. But I think there's other things beyond that. I think, but anyway, I think the general answer really is you're looking beyond the fence line, looking at a community scale, and then you have to customize, I think, into the community need and stakeholder. I think maybe flooding is really most important one. In some other part of the country, I think the combined sewer overflow, they're key. They're spending billions, I think, on those stuff, I guess. So.
Yeah, those are great comments. That actually makes me think about, thinking about boundaries and especially for myself as an engineer, I kind of have the box of things that I think about, right, and consider when I'm trying to make good decisions about things. And that's this whole discussion is how do we widen that box, right? How do we expand that boundary to incorporate more things? And there's research, there's studies out there that show green infrastructure and green spaces that are providing our engineering benefits, right? Our municipal benefits of volume control and rate control and even water quality improvement also can provide social benefits, right? Economic benefits, improved property values, reduced crime and things like that. Even just mental health for the residents in those areas. So thinking about those things, I don't know if anybody has any experience or any comments on, seeing some of these other benefits that is, some of those are especially hard to measure, right? How do you measure or put a dollar to improvements in mental health for residents? That can be really challenging. But, qualitative, have you seen some of these benefits occurring in your projects that you've seen? And is there any ways that you've been able to use that as leverage to do more of that work?
If you don't mind, maybe I'll start that conversation with just, some experience recently on how we're approaching development. I think historically what we see, is we see developments come in, especially to Mike's point, in fringe areas of a metropolitan area where we still have ag land being converted to homes or being converted to industrial development or whatever. And we review these development plans with ponds everywhere, and then the ponds are sort of situated in spots that are in the low point, of course, because that's where the drainage goes. But the housing density or the commercial density is really what's driving the location of some of those ponds and the sizes of those ponds. So where one regional pond is maybe better than 6 or 7 local ones from a maintenance perspective, typically the development is driving those layouts. And so, we think about greenway corridors, we do some study work. I mean, there's an investment with that too. Somebody has to invest the dollars in the study. But when we look at, integrating park space with the regional greenway corridors and, identifying whether or not the downstream resource needs phosphorus or solids removal, or does it need flood control, really managing what those two things look like. And we put stormwater first, we put flood control first, or sustainability first, or even the other fringe benefits like public welfare or health or safety or access to parks or green space. We start to have those things drive those development densities. It's a good way at least to build some new partnerships with developers and understand how regulatory functions play within that game. But I think that's where we try, at least as consultants, to focus on the fact that the city, the consultant, the developer, the regulator, this is a partnership. It's not meant to be combative, and we can get a lot more done if we're all on the same team from that perspective.
Andy, I see the most overlap in my work when I work in parks. So in an urban area, first ring, parks are one of the major opportunity areas to, retrofit in more clean water and flood protection purposes. And the community conversation around what that development is going to look like, how the trails are going to wind through the nature, that's key. Edina has another example in their Southdale redevelopment area. Old 60s, 50s era commercial areas are redeveloping as multi-use. And one of our key goals is to get more of that stormwater daylighted and on the surface so that we can start to realize some of those co-benefits. One of the key challenges behind that is, generally when you're building a stormwater feature, and you have to pay a marginal increase to get those other benefits, nobody else is coming to the table with, the partnership and the dollars. So we're still looking for, how to really align the pocketbooks. And a lot of times when development is making the choices, they're making it towards a least capital cost choice. And even though that the future thing is going to be maintained by a private homeowners association or a commercial entity, a lot of the decisions are made, really just looking at the capital. And I think this life cycle basis is important to that as well, so that you can start to compare long-term and whole of society costs of the infrastructure that we're building.
Yeah, Andy, I guess, and I think to me, I guess Ross is kind of making the case almost that, from a land use planning side, post World War II, we really started letting developers do the planning rather than municipalities. And that's where, again, you kind of go to design. And while, we're loath to talk about the value of regulatory side of it, but the reality is that that's going to be a component of driving decision making. And so Tim and I work together, and really it's kind of, again, this mindset about every component of it. Street sweeping, it's Ross and I and the U have been working on this for a number of years, and that's a case where we're looking at something that's at least within the Forest Lake area. It's $170 a pound, but it reduces the maintenance cost for MS4. So that's an added benefit. Extends street life. What are those? Is it something that could be maybe considered a net sum zero cost? Basically, you just take your existing a program and you do enhanced sweeping, and it provides additional benefits. I think there's another thing that we haven't talked about yet is how valuable data is, from both water quality or other measurability. Harry talked about, flood protection, and we're trying to have that conversation. We're working with EOR to do some H&H modeling and really look at, okay, we just got to just come to a realization that for the last 20 years, Wisconsin and Minnesota has been hit by these 10-inch storms someplace. So how do we then prepare for that to at least give warning to people, set up, the infrastructure for some potential like that, because that, ounce of prevention worth a pound of cure, especially in future design, is, so critical. I just think that there's a lot of other elements. The other one that, we're looking at too on a watershed scale is how data is driving our implementation You know, the Pareto principle is this 80-20 rule where you're looking at this very small number of projects that potentially provide, you know, this large benefit. And I think, you know, at least from my experience in all areas, whether it's stream banks, barnyard restoration, or field scale kind of stuff, that applies, and it's very continuous. So we've been able to look at through data collection, diagnostic monitoring, to find these legacy loads of old sites that are still discharging from wetlands that a model would never tell you about, and have done tremendous, you know, resulted in tremendous improvements in water quality. So, you know, it's just really incorporating consciously this whole element of cost benefit and, you know, return on investment across the board. Because some of these legacy sites, once you remove it, it's a permanent removal. It's not a 25-year maintenance cycle or anything else. It's a permanent improvement to a downstream water body.
So this is Harry. I think I just want to add in one more piece of information. So during the two development, I think that this national association called National Park Recreation Association. They're in suburban Washington, D.C. So they approach the Research Foundation, and then they say, oh, they heard about this. And then their perspective coming from the, like Rod saying, coming from the park, I guess. They want people realize, you know, there's an important value for the park. Of course, people feel realize, but I think how much? I think so. They want to sort of see how we evaluate this, you know, the green space, and then so we share some information with them, and then they come with their own little bit. I think, you know, the briefing to try to get the message across. Anyway, I think, and then the second point was like in the urban sort of area, you know, the urban park is very valuable. And then in some cases within the city government structure, I think this is maybe another department. So this is a cross department, I think, coordination is important. I think a park, you know, the department maybe they maybe heard about green infrastructure, but now like a stormwater people, you know, we're getting into stormwater, but they say, okay, but if somehow you get a message coming to them from the benefit part, I think they green infrastructure, and then they may get a message across. And then when we're pushing the one water city, I think you can think about this cross department coordination, because the park people say, hey, we own the park, we manage the park, you know, you guys, you know, try to, anyway, I think those kind of a partnership coordination is very important.
Yeah, I think that's great. Thank you for those comments. We're gonna pivot a little bit. I want to kind of delve into a question that came in through the Q&A. And this gets at, you know, when you think about cost benefit, there's a lot of, oftentimes you just kind of imagine, we talked about developments, right? Development scale or larger scale, or even in some cases, watershed scale, right? Type comparisons and looking at the cost benefit analysis. Harry mentioned CSOs, you know, they're doing it on a pretty large scale when they're considering CSO cost benefit. But what if we zoom in? Can we apply these same types of principles on, you know, individual site scale, smaller scale developments, when we're trying to make comparisons and make decisions on what's best for a particular site? What would be your experience or your advice on that, scaling it down?
Andy, I'm glad you brought that up, because I was actually thinking about this a little bit here too, and I was going to pose a similar question even back to Ross. You know, you know, I think that regulation breeds a lot of innovation, that we're finding ways to be more cost effective with increasing regulation. Again, you know, focusing on regulation as a tool, but can we modify our regulation? You know, so if we're looking at impervious densities, you know, that are typically 85% in commercial areas, but for redevelopment, can we bump those down to 75%, 70%? Can we push some of that innovation, the expectation for innovation and cost effectiveness back on development? You know, Ross mentioned, and we've been talking about this continuously, somebody's got to make this investment, right? Somebody has to pay for it. And oftentimes it goes back to the community, which of course is a trickle down back to the residents to have to pay for some of that innovation for these multi-beneficial systems. So should we be changing our design guidance? Should we be changing our ordinance regulations to maybe incentivize reductions in impervious surface, or, you know, and incentivize things like stormwater capture and use for irrigation, or, you know, whatever, and again, put that back on the developer a little bit to sort of inspire more innovation and partnership.
Yeah, before I address kind of Tim's major comment, I would say that on the individual scale, cost benefit analysis is important for several reasons. One is if you get it down to an annual, cost per year, you can start to compare it easily against other things in your portfolio like street sweeping. The other reason is, and I think, when you back into these issues from a regulatory approach or from a performance management approach, you often miss this. But, the choice of how big to make something or how small to make something compared to its watershed area can really make or break your long-term strategy in terms of scale. And I think, so Tim's question is, if you look at redevelopment versus the community, where should you be doing stormwater? How should you be weighting those things? When you can start to compare at that individual level and actually look at cost curves, the more and more you do, the bigger and bigger the infrastructure, the less, you get some diminishing returns in that process. And in a perfect world, we would have the right of way and the community and the development and the site, functioning right along that same marginal cost benefit, so that the next dollar that the public invests, anyone's pockets it's coming out of, is doing the most good, right? And we would find a way to saturate like that, but that's not how the world works. We have to build one project at a time. We've got to kind of look forward. But yeah, the individual site basis and the marginal cost benefit and cost curves can be a very valuable thing to kind of understanding how coherent your strategy is when you look at individual types of practices, individual sites against one another. And I would say, Tim, as far as the weight goes, I see the regulation driving an overinvestment on the redevelopment side, where if we were to dial that back by one margin and be able to take the cash off the table and put it somewhere else, we would be able to get tons more benefit than that last margin is paying for on the redevelopment side.
Yeah, Tim, I think, well, I mean, because we work together on some of these. So the several watershed districts have, offered the opportunity. I mean, first of all, you have to do as much as you can on the site. And so, one of the things that I think that we could add to our current framework, because we do offer the ability for a developer to participate in a regional stormwater feature. So, and then that goes to really Ross's point about, where you are on the curve. We've also, just out of curiosity, compiled all of our stormwater practices, cost benefit, and we've arrived over, since 2009, something like $783 per pound of phosphorus. So then, you need to know where that is compared to a whole bunch of other stuff to be able to say, okay, this other practice is 2,000 or 5,000. That's we don't want to ask the developer to do that. Let's bring that back. And that's, I think this is really Ross's point, but we don't currently have a framework for doing that. And that really kind of gets into, whether you're going to call it pollution trading or something else, but or just simply a mechanism that says, yeah, somewhere else would be a lot less expensive. And if we're just from a market standpoint, it seems like that's where we would want to try to get everybody at in terms of from a redevelopment standpoint.
So there's here, I want adding two more pieces. I think a little bit beyond Minnesota. So one is like a individual site. I think the performance is very important, and then you can scale up. I think I agree with all the panelists. I think one example is really on the stormwater harvesting in those kind of the dry regions. I think think about California, Southern California. So I think there's some research showing a very rigorous way. If you get down to a certain scale and then follow certain practice, you can actually have a good return. I think not in that part of the country, you save the water and then become a resources, and then they really immediately give you economic benefit. And then if the scale up, and then you can generate those benefits, I think is important. That's in their sort of a value proposition. Even in some cases, water can be the lifeline, I guess, there. Another example, sort of in the not beyond, so I think those are kind of CSO community. This is in a little bit wetter region, and then they're talking about if I building a green infrastructure, what part, how much per dollar basis that can reduce the CSO flow. Because in the consent decree, they're talking about like a multi-billion-dollar over past, 10 years, that kind of thing. If you can do that and then make that matrix work and a couple of dollars, that's going to help tremendously, I think, in that kind of business case. I think go back to the beginning. So what is a business case? I think in different part of the country, those kind of business cases are different, or stormwater, weather related issue. But I think, go back to the original question, Andy, as an individual thing, it's important, and then you need to scale up. I think, how do you do that? How do you efficient? That's really, we try to using some of the tools to help the decision-making process.
Yeah, that's great. I actually want to take that because we've already mentioned it a few times, right? Oftentimes we think cost benefit. As I said, we think about watersheds. We've now scaled down to sites. I want to pivot it a little bit because, Ross mentioned and even Mike and Tim mentioned street sweeping, right? So that's not a site, that's a management strategy, right? That's a maintenance or a long-term operation concept. Another analogy would be salting, right? Can we use cost benefit analysis to compare conventional salt like sodium chloride to alternatives like potassium acetate or other chemicals, even mag chloride or calcium chloride? How do we use these kind of concepts, these cost benefit analyses, or how have you used these cost benefit analyses to select these kind of alternate management strategies, which again could apply across the entire watershed, but are not what we would typically, in the ground structural type practices?
I thought Ross would jump in on this one. So, but because I'll give him the credit for really when we were both at Prior Lake, and when he was working with the University of Minnesota to kind of start this analysis, and then we 2014 when I got up to Comfort Lake, Forest Lake, I started working with the city, and we did that enhanced street sweeping with Pauline, who's now at EUR, to really evaluate what that benefit was, because from that previous experience, it seemed like this was something that we wanted to at least look at. And I think this is really then goes back to just simply the philosophy of, a community organization, city councils, public works, watershed districts, both in consultants across the board, everybody is just being able to kind of, every time there's an opportunity to take a look at it and say, if, as I mentioned, I say to you guys, my dad had always said, there's only two ways to make money: make more than you spend, or spend less than you make. And if you can do both, all the better. From a public services standpoint, it's how do you provide more service for the same amount of money, or just do the opposite, so you're providing the same service for less money, but if you can do both. So this is kind of where street sweeping really falls into the case here, where we're saying, all right, enhanced sweeping, especially in direct drainage areas, really provide a lot of benefit, both from a water quality standpoint, but it reduces your maintenance costs on MS4, it extends your street life. And those that we haven't even quantified. So just from a strictly phosphorus reduction standpoint, we came in after 2 years of analysis, because we have a scale on the sweeper plus a GPS unit, so we know linear feet and everything, so how much we're removing, and that's come in at about $170 a pound of phosphorus, really low cost. We add in these other additional community benefits. I think you could argue that there's probably nothing we can do across Minnesota that's more beneficial than street sweeping, even compared to ag stuff. Unless, there's maybe just from a design, there's probably some things in land use design things that could be, that fall into that ounce of prevention side. But from a current practice, I think this is really a good example. And, thanks to the university staff like yourself there for helping to initiate these kind of analyses and research efforts.
Yeah, pollution prevention, I think, is key in comparison. I think, when it comes to the capital cost efficiency, when you just look at life cycle or if you want to try to scale up quick, pollution prevention can be some of the best practices to start with. But then I think the one area that we haven't really talked about is, in-lake management. This doesn't fall under our regulatory paradigm, but some of the best things you could do to clean up a water body happen in the lake. So managing fisheries, managing aquatic vegetation, binding phosphorus in sediments. Mike mentioned earlier, the issue of a wetland with a bunch of historic sediment or, nutrient rich sediment just for decades maybe just puking out into the downstream water body, getting ahead of that and addressing it before or as development takes place. Yeah, I think when you think about cost effectiveness, and in my work I think about it in terms of its individual components. One is, okay, how do I spend the capital in the best way, and that has to do with the acceleration and the rate of change and the rate of growth. How do I make sure that the operation, and I think Tim talked about this in maybe the first question, can we extend the life? Can we get another increment of benefit? That equation that is around cost benefit that has the time and the benefit and the cost all in it. It doesn't happen once in design. A lot of the things are set in design, but it happens every year based on how you're operating and maintaining and what so I think it's kind of a continual thing that you got to run on different asset classes. And yeah, you're pulling in data all the time, and sometimes it's good hard data with water quality monitoring behind it. Sometimes it's just incidental, where you're like, oh, I've got a sense for what this wetland is doing here. And yeah, I think you got to investigate them. You got to figure it out and get it into your mental model. It's going to lead you to the best business case going forward.
Maybe just to touch on chlorides too. I mean, I think there's a lot of correlation between street sweeping and chlorides from a pavement longevity perspective and infrastructure longevity perspective. Certainly, excessive chlorides can have real impacts on pavement quality and other infrastructure quality. But the other piece to that puzzle is real safety risk, and trying to manage that, and it's, I think when you become more aware of chlorides, especially in cold weather states, hopefully there are some people on the call that are in cold weather states. I presume there are, but winter maintenance is a challenge. And when you become aware of areas that require excessive salting and you see how much extra salt is being applied, all of that goes right into our resources and it really can't be taken out. And so, when you think about it and you're aware of it, it just seems so, it seems so logical, that chlorides are going to have an impact on our resources. But at the same time, if one person slips and falls and hits their head, that's a real problem. And so the piece I think that's important, and we're even doing some of this with street sweeping, is trying to bring that education piece into play. Why is this stuff important? And we're fortunate here in cold weather climates, and especially in Minnesota with smart salting and other PCA driven programs to try and teach practitioners how to calibrate their equipment and what's the appropriate amount of salt. Looking at private winter maintenance contractors and making sure they know how much salt is appropriate and when to apply it, when not to apply it. I mean, that's a pollution prevention practice too, right, Ross? I mean, it's being able to reduce the source and pull it from the environment before we even lay it on the pavement. So salting, I think, is going to be one of the more important concerns, and it is already, but even more so moving forward. And managing risk is a really, really, really huge part of that.
Yeah, that's one of the few examples that you can get. It's not cost benefit, it's how much you save while also doing good for the environment. Other things like that is if you have polyphosphates in your drinking supply, water conservation can be one of those. But yeah, there's a few opportunities out there where you both save money and do good for the environment. And yeah, if you have a way to monetize that, you can immediately roll it into more of the capital or operations side.
So this here, I think I want to add in two comments. One, I think I fully agree. I think the pollutant prevention, in some cases, source control is very important. I think this goes back to the when we're doing the wastewater treatment. I think that's really the thing in there. So stormwater is no different. You can thinking from that perspective. I think in terms of specific like street sweeping, that kind of thing. So one of the things I want to mention to the group or on the audience is really, so through the 20 plus years on the international storm PMP effort. So for those kind of a non-structural BMP or practice, it's very hard to quantify their, the efficiency or or even some, if you want to get some credit, I think how to get that. I think just follow what Mike talked about. I think in one of the example in Seattle, I think they have done some sort of targeted, I think a street sweeping. I think I try to how meeting their MS4 permit goal because driven by the Puget Sound, I think a specific goal in there. So I think because of receiving water have a very tightened ecosystem quality standard. I think so that's why. But anyway, I think that in general, sort of non-structural BMP is one of the actually research topic. People know there's good. I think about how good and how do you quantify. This is connecting to the. As a business case, you need a data. I mean, those kind of data is really, you have to well design the data, putting the research into it in a rigorous way, and then people believe it. So it's hard. The second piece of comment relating to the road salt, I think, as far as I know, there's alternative to the regular road salt. I think can be using. I think a challenge. I think this is through the National Research Council, Highway Research Program, show that. I think of course one thing is really the cost. Okay. The tremendous more expensive, and then the other thing is sort of a maintenance. How do you save those kind of stuff, And then in the reality, this is a coordination between transportation department, DOT, which their primary goal is really public safety. I think this is a sort of a sort of secondary. But anyway, I think this is sometimes they have those kind of conflicting per se, and then or trade-off. You have to balance the trade-off, and then in there, and then the. One example triggered me was like incentive in the stormwater sector. Some of the municipality or they give people incentive to install like a porous pavement on your paveway. So it's about 2 or 3 times more expensive, but I think they give you some credit. So they give you some of the sheet, and then you pull it out and you type it in your thing, and then okay, I'm break even. So I want to do both good for environment and also the municipality give me an incentive. In that case, people will do the porous pavement, I guess. But in this case, I think the road salt, maybe I want to. I think my sense, I think is really the gap still big. I think this is people try to use the best available material, the thing in there. But my gut feeling because that gap, and also the people applying the salt, there's some sort of a skill set in there. In the wintertime, you just have no time. You have to store the salt and apply. Anyway, I think it's a tough issue. I think I want to. Put out there is not clear right now the trade-off. What is the best trade-off? I think that's really maybe that's something we can discuss in the future. Yes.
Yeah, that's great. So go ahead, Mike. You want to chime in?
Oh well, just yeah. I think again from a design standpoint, and and just talking about these incentives, I think Carrie makes a great point, and that's what I was kind of leaning toward was just we don't like to use porous products, or especially near in sidewalks things. But my neighbor last year tore ACL or something. She was laid up for a few months because she was trying to walk into a school program because of the ice. But had it been porous, just think about those other benefits of not having all those medical expenses. We don't figure those in at all. So is there a way that maybe again, it's really a hard sell to city councils, but maybe you say, all right, we have a stormwater fee, but maybe we have a chloride fee. And then that you could get credit for if you are doing preventive things, but again, it really adds a very complicated element to a lot of different things. And we'd like to certainly figure out how to get there, but I think it's up for discussion. And again, it kind of goes to to this design element and how do you pay for it really?
Well, like you said, Mike, and Ross did too. If you can save money and still provide benefits or do your benefits at less cost at the same time, that's always a win-win, right? But I'm gonna be a naysayer. Okay, I'm gonna be an opponent here. I'm gonna throw you out a question here. Well, okay, what if I have to choose the low cost option? What if I'm legally bound, right? Public bid or whatever it happens to be. How have you been able to choose maybe the more environmentally beneficial choice or the long range beneficial choice over a lesser cost choice? You know what I mean? Because at the end of the day, it's all the bottom line, right? You got to spend the amount of money you have, and we got to get more done. blah, 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 right? So how do you choose those sometimes other more expensive choices? How do you get around that?
Partnerships. So when someone is, stuck, the incentives are wrong. I think this type of life cycle cost benefit, this type of triple bottom line or multi-benefit thinking can suddenly bring partners to the table. So we've seen that in natural resources and parks projects where our city stuff aligns with watershed districts. We've seen it on redevelopment projects where our sustainability goals align with the long-term operation costs of the people who are going to live there, or the ultimate tenant, not the developer. But generally, yeah, someone sits in the decision chair. It's just a matter of, can you get that partnership and the deal in front of them in time? Are you nimble enough to be, or responsive enough to get to the table so that you can make the partnership project with multiple funding sources rather than the no-brainer, the turnkey, the status quo.
One step in addition to the partnership piece, and they're really correlated, is the planning piece, right? So investing in the plan really helps. You tend to see, especially very implementable, near-term plans. If it's a 5-year versus a 10-year versus a 50-year plan, that kind of will change the scale, and you see that in comprehensive plans versus local sub-watershed assessments, where we can actually stack projects out in a reasonable timeline. And adjust our funding sources based on that, and then with partnerships, we can look at what's the regulation versus what's above and beyond. There are a lot of willing partners, at least in this state, that want to invest in more expanded infrastructure. And so that plan is really critical. Otherwise, we're back to square one, right? We're back to piecemeal approach. We're back to individual, maybe really expensive underground systems. We're back to, residential developments that have 30 ponds in them that, ultimately all discharge at the same time. Let's remember that we're doing our best to restrict rate out of a lot of these ponds, but at some point the timing of those peaks is going to coincide again, and probably result in a much higher rate than we ever intended. So again, if we go back to the plan and a community or a county or a state partner is ready to invest in the plan early on, I think that can be a very small investment when we think about the long-term gain from expanded resources.
Yeah, I think just maybe a little bit on that side too, and I think the planning part is really critical. And then it's also the sequencing, because when we can all drive around any major metropolitan area really around the country, and probably, the first 30 miles outside on any major roadway, you've got signs for sale of undeveloped land. So, and often, both the cities and, watershed districts or other regulatory elements are, we often get put in a hard spot, because all of a sudden, we can't see anything until it's brought to us and say, maybe they've done a bunch of surveying, the design work, spent some money, and they go, well, this is what we want. And we're like, well, had you talked to us at the beginning, this is maybe what we would have liked to have seen. So, how do you get in front of that again? And I kind of think it goes really, one of the big missing elements of future costs is going to be getting in front of the planning design phase, and again, for the last, 75, 80 years, we've really let developers lead that development side rather than municipalities saying, okay, here are some frameworks. And I know that that's not maybe a very favorable thing to comment on at this point, but it's just a reality is that people maybe don't like the regulatory side, but we have to come to the table after something is already put in front of us then, and it creates more of a challenge, I guess, for all parties, unfortunately.
Proaction versus reaction requires some significant thought and maybe systemic change, systematic change.
So I want to add maybe another two information. First, I think I agree on, partnership is very important, and in some cases, a partnership can come with potential opportunity for co-funding. I think if you seek co-funding, I think of course you want to get in the value proposition out. I think I think sometimes as a professional here, I think I feel within a stormwater sector, sometimes the value proposition is harder than other type of waters, just because people, oh, they can, oh, I drink water, okay, I pay the bill, that's fine. Okay, I dispose wastewater. Where is the stormwater? They just just rain. I think something like that still happens, because this is a sort of, in order to get a wider support, I think people have to feel they can touch. Okay, I got the stormwater services. Okay, what is it? Okay, so I think that's part of the partnership, maybe the messaging in some cases. I think the other thing sort of on the sort of future planning, future cut, I think that's very important. I agree. One of the things that triggered me to think about like on TMDL, I think in the TMDL, one of the steps they call an adaptive management process, meaning on the regulatory framework, on the deadline, they have to get a TMDL approved with the data at that point in time. And then they offer, okay, if you have more data, more resources, you can adapt to that type of approach. The reason is, the TMDL on the limited data may be very stringent for causing lots of, the limits for you. And then later on, you may have incentive to collect more data more in a more rigorous way doing the TMDL. And then what result into for you really benefit you, because the original assumption was not accurate. Okay, so this is an adaptive approach, and also for the BMP performance in the future, with thinking about the climate impact, that kind of thing. One example like this, for those kind of, again, maybe the CSO community, maybe a better example. So when they design the pipe, they have something in their mind. Okay, this is going to meet the consent decree. But later on, they after 5 years, they didn't. The reason they say, well, they blame the precipitation. Well, we got too much extreme precipitation that year, got overflow. And then why is that? Because we design based on the data. But then should we consider future trend? And then so those kind of things in there. So based bottom line, really, you overflow more, and then what's the appropriate pipe size for you in the future? So those kind of adaptive proactive approaches are very important.
So I want to get into maybe one of a difficult question. I want to ask about barriers and challenges. I mean, this obviously this is not the easiest thing to do in the world, right? Otherwise, everybody would be doing it, and people would be doing, and people are doing amazing things with this. But like Mike said, it's just not a conversation that comes to the forefront very often. We don't talk about it very much. I feel like people struggle with doing cost benefit analysis, triple bottom line, valuation of some things. So what I'd like to do before we close is, what are your biggest barriers and challenges when you're trying to do this work, or when you have clients that are trying to do this work, or partners that are trying to do this work? What are our barriers so that we as researchers and industry partners can think about how do we advance this topic?
I mean, I'll say it, it's money. I mean, that's a big part of it. That's why the funding partners are such a huge part of that. When we try and do it at the local level too, and we're, meeting the basics and managing our natural resources from that perspective, whether it's mandated or not, a lot of that still comes back to who's investing. So that's an initial thing. That's probably overstating the obvious too for this group, but money's an important piece.
I'll go next. I think when I think about the two other utilities that I help manage, the sanitary sewer and the water main, we've got customers willing to pay. We've got a recognized value, and we've got a business case that has those things assumed at scale. We don't have that in stormwater management. So what do we need? We need people connecting on the benefit. We need a better understanding among the customer. We get paid for what doesn't happen, right? The lake wasn't be green. You didn't flood. So recognizing that some of this is insurance and maintenance. It's not sexy. And then when I think about the key technologies that we have for clean water, when I multiply those out, even taking an investment that's half the size of the sanitary sewer system or half the size of the water system, I can't get to scale before I run out of money. So I think we need technology that can get us to scale. And I think this optimization question and this, partners and managing for multiple benefits question is key to that. So I am having these conversations, but they're happening at a really high level in the governance structure. The councils understand our business case, they understand our service. It's just connecting that down to the public level.
Yeah, thanks. I think maybe for me, I would add on that, policy, at all scales really drives things. I mean, I'm very involved on the ag side, and we have a scenario where agriculture is rewarded for more productivity, not for environmental benefits. So there's a lot of opportunities for, grass-fed agriculture is way more cost beneficial to produce than confined, but there's a lot of incentives on the other side of it. So it's just hard to compete. So, there's a case where I know Ross has said, get to eat for water quality, find those sources and spend that. But I think even, locally, again, this really comes into a scale element, because I think there's plenty of, I feel like there's plenty of money, we're all spending money. One of the things that from Tim's side, and I've suggested this to other consultants in the past, is to, hey, hire an economist or a really good accountant to help your engineering staff do this kind of calculations, and help understand help your team understand that. So, I feel very fortunate in my work that I've run across a lot of good folks like yourselves, and currently, with the OR, we do, they know that this is my expectation on everything we do, and no matter what the size is, it's got to include a cost benefit analysis component before I'll bring it to the board for consideration. So, and because our time is limited, we have public funds as well. They're competing again for other services within the community. And I recognize those as my dollars. And so I want to be as judicious as possible with them.
This is here. So more from the applied research perspective, I think, first thing really, there's a need for getting more hard data. I think, especially on the cost, I think people really like to see the real data. I think like Zhang mentioned at the beginning. So the question, okay, and also how those data, do they collect in a very similar way so people can reference to that? I think that's very important. On the benefit side, I think, there's still some research gap. I think Zhang made a good comment. I think like ecosystem services, those kind of things in there, we're using some sort of quote unquote best available approach so far, but I think that, hey, there's still some gap in there. There can be more. But if too complicated, I think people say, well, can I really use it or something in there? But anyway, I think this is a sort of line between applied research. The last thing I want to say, I think, relating to, my comment, I think it was like, there's a user story. So in order to get a message, people tend to learn from those kind of, peers, or say, oh, have you been successful using it? Oh, in my place, no, they're going to reject that. Okay, anyway. So those kind of user stories, including, success story and also lesson learned, which is hard to get, I guess. So in any case, I think sort of encouraging people sharing information that may be important, but maybe they can, if nothing else, a peer-to-peer network, I think that's also be beneficial, I guess.
Yeah, that's great. So we will move into the close. And to close here, I would like to ask this final question for all of our panelists. And it is, what are your key takeaways today from this conversation? What do you want to reemphasize from all the things that we've discussed to make sure that our audience has the best points to take away from this to make differences in the jobs that they're doing, right? Both today and tomorrow and for the future. So we're going to go through the same order that I introduced everybody. So Ross, you are up first. What are your key takeaways from today?
Just got to get as much juice as you can from the squeeze.
That's right. That sums it up, right? That's all about efficiency. Mike, what would you say is your key takeaways today?
I just think, supporting each other in this endeavor towards, just bringing this conversation to the table, because not everyone has either heard the message or understands it. And, so just being supportive, across the board to all of our partners, because again, we're all working towards this this thing, for environmental stewardship together.
No, that's great. Tim, what would you say are your big key takeaways today?
I'm not going to lie. My biggest takeaway, I think, is just in this last couple of minutes. I want to thank Ross and Mike for reminding me that cost is a perceived barrier. That if we can change that mindset a little bit and we can actually, do these assessments that are more meaningful and looking at the bigger picture, that cost is really only a perceived barrier. So yeah, thanks for that, guys. I appreciate that. It's so easy to hear that as the continuous dialogue that we don't have enough staff, we don't have enough equipment, we don't have enough money to do it. But there are ways to get around that. So yeah.
That's great, Tim. Harry, you get the last word. What are your key takeaways for today?
So first, I want to thank you for the invitation to be here, and also I learned a lot from the expert panelist from myself. I think, and then I believe using a life cycle cost and then the benefit analysis can help bring the business case. I think in reality maybe is still hard in some cases. I think that's why we're here discussing. I think a year from now maybe we're discussing again still some barrier there, because this is something in there. If something magic can sort it out, I think that'd be great. But I think the matter is so I think we just take maybe like say look in the future, just keep working on this one as a working together. Yeah, see how far we can go. Yes.
Yeah, I think that's exactly it. Just keep working together, keep trying to improve and do better, and let's learn from each other, right? Let's partner and let's learn from each other. So those are great words. I do want to thank everyone for joining us today. I want to thank Harry for giving us our keynote talk today. I want to thank our panelists, Ross, Mike, and Tim, for serving on the panel and answering these questions. I want to thank you, the audience, for joining us, for providing the questions, tuning in. If you are interested in professional development hours, you can contact me, Andy Erickson, directly for that. And with that, I look forward to seeing you at a future Minnesota Stormwater Seminar Series event. Enjoy the rest of your day. Thank you.